So when I substitute AC, it is x2 minus x1 whole square plus BC, which is y2 minus y1 square, is what I get for AB square. So when AB square is this, that implies my AB is nothing but root of x2 minus x1 whole square plus y2 minus y1 whole square units is what I get when I find the distance between 2 points A and B. So the formula says that the distance between 2 points A and B is given by the formula root of x2 minus x1 whole square plus y2 minus y1 whole square units, is what is the derived formula for the distance between 2 points. Note that this formula is called the distance formula, which helps us in finding the distance between any 2 points on real xy coordinate system. The formula referred as distance formula. Now let's take an example problem to understand the distance between two points applied in the given problem. Say for example, I have the question which says find the distance between the points 4,2 and 8,6. Then in order to find the distance between these 2 points 4,2 and 8,6, I use the distance formula which we have derived very recently. So before we start with using the formula, I take the points P 4, 2 and Q 8, 6, which when compared with the general formula makes me utilize this as x1 and this is y1 and this is x2 and this is y2. So x1, y1, x2, y2 are all the 4 values given. Therefore, from distance formula, I have the distance PQ, which is given by the formula root of x2 minus x1 whole square plus y2 minus y1 whole square, wherein I substitute each of x1, x2 and y1, y2 from the given coordinates, which when substituted gives me root of x2, which is 8, minus x1, which is 4 whole square, plus y2, which is 6, and y1, which is 2 whole square. This, on further simplification, gives me 8 minus 4, which is 4 of square, 6 minus 2, which is 4 of square, and this is 16 plus 16, which gives me root of 32. Now root 32 can be written as 16 times 2, which can be further split as root 16 times root 2, and the purpose of splitting the factors is that I have this as a perfect square. Therefore root 16, which is 4 root 2 units, is how I get the most simplified answer for the distance between the 2 points P and Q taken in with the formula. The distance formula applied for a given problem is 4 root 2 units in distance. So collinear points. What are collinear points is the mathematical question in discussion of this topic. So what are collinear points? Collinear is the word which is used for the points identified on a line. Linear is the word extracted from this, that means straight line. So collinearity is related with a straight line. So what are collinear points? I say points A, B, C are collinear. These three are said to be collinear if they lie on same line. That is, if I take the line L, which has all the 3 points A, B, and C, then I say that these 3 points are collinear. If I have any other point D, which is outside of, then A, B, C are collinear, but A, B, C, D are not collinear because this is outside of the line. For the points to be collinear, I need to have all the points on a fixed straight line. Therefore, for the points A, B, C to be collinear, all 3 must lie on same line. This is how we understand the collinearity. So how do we solve problems where we have to justify whether the given points are collinear or not? So let's connect collinearity with distance, which says that mathematically A, B, C are collinear if I see the straight line AB plus BC is AC, then I say the 3 points are collinear, because if I add AB and BC indirectly, I get AC. So when I connect this with the distance, ABC are collinear if AB plus BC equals AC is an important formula I take in solving problems related to collinearity. So when I want to show that the 3 points are collinear, I find AB plus BC and I find AC. If these 2 quantities are equal, then I can say the 3 points are collinear. So let's follow this concept through an example problem and see how we can prove for 3 points to be collinear. So let's take a practice problem to identify the collinear points. The question is, are the points A, which is 1, 5, and B, which is 2, 3, and C, which is -2, -1, collinear? This is the question I have. So I wanted to know if these 3 points are collinear. So we have to use the property. I have the definition for collinearity. I have the definition which says AB plus BC must be equal to AC. For collinearity, AB plus BC must be equal to AC. Therefore, let's simplify the left hand side and the right hand side and see if both are equal. So coming to the left hand side, I have AB plus BC. So initially let me calculate AB and then BC individually. So what is AB? It is the distance between 2 points where this is x1, y1 and x2, y2. Now using the distance formula, this is x2 minus x1 whole square plus y2 minus y1 whole square is what I get when I use the formula. Now this comes out to be 2 minus 1, which is 1 square, plus 3 minus 5, which is -2 whole square. So this is 1 square plus 2 square, which is 1 plus 4 root 5. So this comes out to be root 5 clearly when I add each of the terms. Similarly, let me find BC, which is the distance between the points B and C, where this is x1, y1 and this is x2, y2. So root of x2 minus x1 whole square plus y2 minus y1 whole square, which on simplification gives me -2 minus 2, which is -4 whole square, plus -1 minus 3, which is also equally -4 whole square, which gives me 16 plus 16, which is root 32. On simplification, this is nothing but 16 twos, 4 root 2. So I get this to be 4 root 2 and this to be root 5. Then finally, let me also find That implies my AB plus BC is root 5 plus 4 root 2. So this is what I get on the left hand side. Similarly, let me calculate the right hand side, which is AC, and see what I get out here. So let's take the right hand side. My right hand side, which is AC, is calculated by taking this as x1 y1 and this as x2 y2 between A and C. Therefore, using the distance formula, I get here root of x2 minus x1 whole square plus y2 minus y1 whole square is what I get in simplification. And then minus 3 whole square plus minus 6 whole square, which on simplification gives 9 plus 36, which is 49, or root 9 plus 36, 40. This comes out to be 3 root 5 is what I get for AC. But clearly I can see that AC is 3 root 5 and AB plus BC is root 5 plus 4 root 2. They are not equal. So from 1 and 2, I can say that AB plus BC is not equal to AC. Hence, ABC are not collinear. That implies ABC are non-collinear. That is, the 3 points do not lie on a same straight line. If the left hand side was equal to the right hand side, then I could have said that the points are collinear. But since the left hand side is not equal to the right hand side, the points are non-collinear, is how we justify the given points for collinearity or non-collinearity. Now let's see what the section formula is for internal ratio. Now before we discuss the section formula and its derived formula, let's understand what exactly is a section formula for internal ratio. That is, if I take a line and if there's a point between the line joining the 2 points, then we say that point divides internally in the ratio. Say for example, I take the line this. If the line AB is with the coordinates of A and B, then if the point P divides AB internally, then we say this divides internally. If P is outside of A and B, then we say P divides AB externally. So in this case, point P is between A and B. Therefore, the point P divides the line AB internally, and just we have this dividing in some ratio, say M and N. So this is a section formula because we have the section of the line which is divided by the point P. So when P divides AB internally in the ratio M and N, we get the section AP and the section PB, which are independently calculated by using the section formula. So let's see how the section formula can be constructed using the real XY coordinate system. So initially I will take an XY coordinate system out here with x-axis and y-axis and the origin, which are taken all together. Now from this, I wanted to take the line AB in the first quadrant of XY coordinate system. So let me take the line AB somewhere here. The point A is here with x1 and y1 coordinates, and the point B is here with x2 and y2 coordinates. And then let me say there's a point P which divides AB in the ratio m:n, where the coordinates of P are x, y. So here I identify that P is the point which divides AB internally in the ratio m is to n. This is how I get the picture on real xy plane. So this is m and this is n in which it is dividing. So let P divide AB in the ratio m is to n. Then I wanted to find the coordinates of P. The question out here is to find the section formula, that is the coordinates of P. So what are the coordinates of P? So using the picture of the coordinates of A, which is x1, y1, and coordinates of B, which is x2, y2, and the coordinates of P, which is xy, I clearly identify that if I drop a perpendicular, and a perpendicular, then let me take the respective A dash, P dash, and B dash on x-axis, where my A dash is exactly at a distance of x1. So this is x1, and this P dash will be x, and this B dash will be the x coordinate, which is x2, is how we get here. Now let me drop a perpendicular from A to the line B, B dash. So if I drop a perpendicular here, say this is some C, which is a perpendicular dropped on this line, then I'm going to use the concept of triangles. So here I get two triangles when I drop the perpendiculars and join A with C. Again a perpendicular dropped on this line. I get triangles ADP and ACB, which are the two triangles which I'm going to consider in my initial case. So here I identify that from this diagram. Consider triangles APD and ABC clearly are said to be similar, because as you can see here, these two angles are equal, being the corresponding angles for the two parallel lines. So this is one angle which is equal, and this is 90 degrees, and one is the common angle. Therefore, by double A similarity, I can say that the two triangles are similar. So for triangles, I can say that clearly triangle APD is similar. The symbol for similarity is this. So triangle APD is similar to triangle ABC. So I get the two triangles similar by double A similarity, since by AA similarity theorem I get the two triangles similar. Now we know that when two triangles are similar, we have the property that the corresponding sides are in same ratio, the similarity property which we have discussed in the previous sessions. So the two triangles similar implies corresponding sides are in same ratio, that is AP by AB will be equal to AD by AC, AD by AC, which in turn is equal to the third side PD by BC, is what I get as equation 1, the corresponding sides in same ratio. But as I see here, I clearly see that AP is nothing but M, which I get from the ratio which I have identified here. And similarly, my AB is M plus N, because AB is AP plus PB, therefore M plus N. Therefore, in place of AB, I get M plus N is what I get. And similarly, my AD, which is nothing but here, is nothing but equal to A dash P dash, which is X minus X1. So therefore my AD, which is equal to this, is the whole of x minus x1 gives me this. So this can be taken as x minus x1. Similarly, my AC is nothing but equal to a dash b dash, and this is nothing but the whole of x2 minus x1. So therefore this minus this gives me this, which in turn gives me this. Therefore my AC is x2 minus x1 is what I get. Now to continue further with PD, let's see what I get with respect to the y coordinates. To find PD, let me drop a perpendicular from here to here, where this and this and this. Now this is clearly the coordinate y, and this is clearly the coordinate y2, and this is clearly the coordinate y1. So here I get y2, y and y1, which are nothing but for b dash, which is already obtained. So I take this as b double dash, p double dash, and d double dash, a double dash is what I get for this. So once I know these to be y2, y and y1 along y-axis, let's see what would we get for PD geometrically. So as I observe PD is nothing but equal to a double dash p double dash, which is nothing but the whole of y minus y1. So y minus y1 gives me this, which in turn gives me PD. Therefore, the whole of y minus y1 is equal to PD. So PD is substituted with y minus y1. Similarly, when I want to find BC in the similar grounds, let's see what is BC equal to. In this diagram, the BC is equal to the length of a double dash b double dash, which is nothing but the whole of y2 minus y1, which gives me a double dash b double dash. So this length is the whole of y2 minus y1, which in turn is BC. Therefore BC is equal to y2 minus y1. So I get this as y2 minus y1. Now once I got all the three equations, then let me take this as equation 2, from which I take the first pair and then the first and third pair and simplify separately for the first pair and the second pair. So let's take the first and the second ratios together to see what exactly I would get in simplification. So in case of this, from equation 2, m by m plus n is equal to x minus x1 by x2 minus x1, which on cross multiplication gives me mx2 minus mx1 is mx minus mx1 plus nx minus, so let's not expand this, but I take this as m plus n times of x minus m plus n times of x1. So this multiplied with this minus this multiplied with this is what I get in the cross multiplication. Therefore this on further simplification gives me m plus n times of x. Now in this case I take m plus n into x on one side of the left hand side, and this on the remaining side I get mx1 plus nx1 plus mx2 minus mx1, which is again the same. This on simplification gets cancelled. Therefore I get this to be mx2 plus nx1 is what I get. Therefore this equals to this implies my x coordinate is mx2 plus nx1 by m plus n is what I get for the x coordinate. Similarly, I take the first and the last to get the y coordinate of P in the similar derivation. So let's see how the y coordinate is obtained by taking the first and the third ratio of equation 2. So again from 2, I'll take the ratio first and the third and find the y coordinate. So in this case, from equation 2, the first ratio, which is m by m plus n, and the second ratio, the third ratio, which is y minus y1 by y2 minus y1, is what I get when I take the first and the third ratio. Then I cross multiply to get the value of y in the similar grounds as that done for the value of x. So on cross multiplication, this gives me m plus n times of y minus m plus n times of y1, which is equal to m times of y2 minus m times of y1 is what I get. Now further simplifying this, I take only y coordinate to the left and the rest of the coordinates there, implies my m plus n times of y is equal to my2 minus my1, which is this, and this one brought to the right gives me plus my1 plus ny1 is what I get when I take all the terms to the right except the y term, which is kept on the left. So with this y term, I can see that clearly plus my1 and minus my1 get cancelled. Finally, left over with my2 plus ny1, which is left over. Therefore, this equal to this implies my y coordinate is my2 plus ny1 by m plus n, which is the y coordinate of P. So with the x coordinate and the y coordinate, which is obtained in terms of x1 y1 and x2 y2 and the ratio m is to n, I get a derived formula for finding the point which divides AB in the ratio m is to n. So indirectly, getting the values of x and y is nothing but getting the coordinates of P. The P, which is the point which divides the line AB in the ratio m is to n internally. So let's write the coordinates of P. Therefore, we conclude that if there is a straight line joining the points A and B with its coordinates x1, y1 and the coordinates of B being x2, y2, then the point P, which divides AB internally in the ratio m is to n, say for example this P divides xy in the ratio m is to n internally, then that internal ratio of the coordinates of P is given by, if P divides AB internally in the ratio m is to n, that implies the coordinates of P are given by the formula mx2 plus nx1 by m plus n and my2 plus ny1 by n plus n is what is the derived formula, which is called the section formula. This formula is called the section formula. Its x coordinate and the y coordinate are given respectively, with the ratio being internal in m is to n. Now let's see an example problem through which we understand the internal ratio concepts more better. As we have derived the formula very recently, let's take a problem connected to the derived formula. For example, the question is, say I have the line joining the 2 points. This is A and this is B, where my coordinates of A is minus 6, 10 and my coordinates of B is 3, minus 8, and this divides in the ratio, there's a point P which divides in the ratio 2 is to 7. So P divides AB in the ratio 2 is to 7 internally. Now I need to find the coordinates of P. So the question is, what are the coordinates of P for this given problem? So clearly we know that here my m is to n is 2 is to 7. That implies I take m as 2 and n as 7 clearly. And similarly, this is my x1 and this is my y1 and this is my x2 and this is my y2. Therefore, using the formula, the section formula, which says that P, the coordinates of P using the section formula is given by mx2 plus nx1 by m plus n. And similarly, the y coordinates are given by my2 plus ny1 by n plus n. So let's see how we can get the coordinates using this formula. So clearly I have m, which is 2, and n, which is 7, and x1, y1 and x2, y2 are also given. Therefore mx2 will be 2 times of 3 plus nx1 will be 7 times of minus 6. So that I get this to be this by m plus n. Similarly, my2 would be 2 times of minus 8 plus ny1 would be 7 times of 10, which gives me 70 by m plus n. Now further simplifying this, let's see what I get here. This would be 2 times of 3, which is 6 minus 6 sevens, 42 by 2 plus 7, which is 9. Similarly, this on simplification gives minus 16 plus 70 by 9, which has to be simplified further. So 6 minus 42 is minus 36 over 9, and this 70 minus 16 is 54 by 9 is what I get on further simplification. This can be further simplified to get 9 ones, 9 fours, 9 ones, 9 6, so that this is minus 4 comma 6. Therefore, the coordinates of P are identified to be minus 4 comma 6. So we understand that the point which divides AB in the ratio 2 is to 7 is minus 4 6. Therefore, P equal to this divides AB in the ratio 2 is to 7 is how we understand the concept of a point dividing the line internally in the ratio m is to n. Now let's take the special cases where P divides AB in a special ratios. Initially, to start with, say for example, I have the line AB for which P divides AB in the ratio k is to 1. So if P divides AB internally in the ratio k is to 1, so let's see how the formula reduces. Now as I can clearly see here, the coordinates are fixed as x1, y1 and b as x2, y2, but my ratio, which was m, reduces to k and my n reduces to 1. M is to n is k is to 1, therefore m is k and n is 1. Therefore, my formula, which says the coordinates of P are mx2 plus nx1 by m plus n, and similarly my2 plus ny1 by m plus n reduces to substitution of m equal to k and n equal to 1. Therefore, when I substitute m equal to k, I get here kx2 plus 1 times of x1 because n is 1 by m plus n reduces to k plus 1. Similarly, my y coordinate would reduce to ky2 plus 1 times of y1 by k plus 1, which on further simplification gives me the formula kx2 plus x1 by k plus 1 ky2 plus y1 by k plus 1 as the coordinates of the point which divides AB internally in the ratio k:1 is how we understand this as a special case. Now that we have derived a formula for finding the coordinates of the point which divides the line internally in the ratio m:n, also we have a special case of understanding can we identify the midpoint of a line, because a midpoint is a point which is equidistant from both the coordinates on either side. So when I take P is the midpoint of AB, I say PA is equal to PB. In that case, what will be the ratio? For a midpoint case, let's see what the ratio is. To restart with the midpoint case, if P is midpoint of AB, then we have the coordinates of A and B which are fixed as x1, y1, and the coordinates of B which are fixed as x2, y2. But since P is the midpoint, it is equidistant from A and B, this equal to this. Therefore, in this case, because these two distances are equal, I get equal ratio, so that this becomes 1:1. Let's see how. That implies from here I get PA equals PB. So when these two distances are equal, I always guessed that implies I get the ratio which is always 1:1. This is very important. For a midpoint, the ratio is 1:1. So in this case, since the ratio is 1:1, that implies my m equals 1 and my n equals 1. Since this is in the form of m:n, with m equal to 1 and n equal to 1, I get the values of m and n. Now, as I have the formula for finding the coordinates of P as mx2 plus nx1 by m plus n and etc. for y, let's see how this reduces to. Since my m equal to 1 and n equal to 1, therefore, when I use the formula for P equals mx2 plus nx1 by m plus n, my2 plus ny1 by n plus n reduces to the form m being 1 and n being 1, 1x2 plus 1x1 by 1 plus 1, 1y2 plus 1y1 by 1 plus 1, because m is 1 and n is 1. So this, on further simplification, gives me, when arranged, x1 plus x2 by 2, y1 plus y2 by 2, which is generally called the midpoint. P is called the midpoint of Phi, and this formula is called midpoint formula. So the midpoint formula says that x1 plus x2 by 2 and y1 plus y2 by 2 is the midpoint formula. Therefore, the midpoint formula says that to identify the point which is exactly equidistant from A and B on the line L can be found using the formula x1 plus x2 by 2, y1 plus y2 by 2, the midpoint which we call as the coordinate of the point P. Now let's do one of the practice problem to find the midpoint. So for example, I want to find the midpoint of the line joining A and B, the coordinates of B, A which is 3, 0 and B which is -1, 4. As we know that the midpoint is exactly the point which lies equidistant from A and B on the line, so let me denote this with M as midpoint, M for midpoint. So to find the distance, the midpoint of AP, MA is equal to MB, and the midpoint formula which says from midpoint formula I have M equals x1 plus x2 by 2 and y1 plus y2 by 2. This on simplification gives me x1 plus x2 by 2 and y1 plus y2 by 2, which on further simplification gives 3 minus 1, which is 2 over 2, and 4 over 2. This gives on cancellation this. Therefore, M equals 1, 2 is said to be the midpoint of AB. Is how I understand the midpoint concept. M is said to be the midpoint of the line AB. Is how we find using the midpoint formula. The point which is equidistant from A and B on the line L.